I'm very excited to introduce Katie Hurlingshaw from the University, I'm not of Norway, which is up in Svalbard, called Eunice. And I'm sorry, I do not have the whole name in front of me. And she is a researcher there who has worked on Aurora up there and is getting into citizen science. And she's going to be telling us about a project that involves both of those things as well as astronauts, which is very exciting. And also Donna is that we know, Donna Locke from Manitoba, who's a great ambassador and also part of this Arctic Citizen Science Group, international group. And they have been working on a handbook for citizen science and a field guide. It's two pieces. Sorry, I'm getting the names wrong, but I think you guys have just released the first version of that, and we're very excited to hear from you both about both of these pieces today. And yeah, I'm not sure which one you would like to start with. So take it away, Donna and Katie. Thank you.
Thanks, Liz. I'm going to talk for maybe 15 minutes about Solar Max and a little bit about Aurora research on Svalbard. And then I'm going to hand over to Donna to talk about the field guide and her experiences in Arctics. And then I'm going to talk about the handbook and my experiences as well. So we thought we'd maybe do it a bit back and forth so that you don't have to listen to the same person for too long. So I can share my screen. Um, and let's see how this works. So now you see the notes, but then I will get them away somehow. Um, Bear with me.
I don't see the notes. I think it's
Oh,
now I
you
see them.
don't. Now you see the notes.
Yeah, it was okay.
Oh no, but where did it go then? Um, I don't know how to switch it back actually. Uh,
There's a
oh,
swap
it's on the
display.
other screen now. It's on the other screen now.
Yeah, cool, you got it.
Did it work? Yeah, okay, good. Um, yes, so now the presentation is up. That's great. So the title of the presentation is Solar Max Uniting Researchers, Astronauts, and Citizen Scientists. And yeah, me and Donna are going to be presenting today, and there is a couple of institutions that are involved. I guess you can't see my laser pointer, right? I have to select that especially, or um, do you guys know how to do that?
No, I don't think it. I think you normally can, but we're not seeing it. Oh, there it is. There it
You
is.
see it?
Yeah.
Okay, perfect, because I kind of point a lot, so that's important. Uh, yeah, so if you scan this QR code, you can go to the website, which is www.solarmaxmission.com, and that's the project website. And here we see some of the features that we're interested in. So these fragments that I'll talk a lot about, and then this like continuous emissions that is a little bit similar to Steve. Um, but first, I wanted to kind of show that, yeah, there's a lot of people involved behind this project. So the Arctics Group stands for Aurora Research Coordination towards Internationalized Citizen Science. And this has been a group of people that's also been growing as well and involves quite a few people on this call as well. So yeah, there is a lot of people behind these guides. For the Solar Max project, that's a little bit more concentrated on my research, but I think it's makes a lot of sense to link the two because we have these amazing resources. And also we have the Fram 2 astronauts. So that's the space mission, the astronauts that will be involved, and there are their names there as well. So they're a big part of this project. Who am I? I'm originally from England, but I moved to the world's northernmost town on Svalbard 8 years ago. And the town is called Longyearbyen. So that's where I did my PhD postdoc, and now I run my own project, which is supported by the Research Council of Norway, and I research what I'm calling kind of strange types of aurora. Um, And this is the place where I work. So this is the University Centre in Svalbard, or UNIS, and a couple of friendly reindeer in front. And this is the world's northernmost higher education institution. And it has kind of like courses in and research in biology, geology, geophysics, and technology. And I work in the Arctic geophysics department. So we also have this facility as well called the Shell Hendrickson Observatory. So we have domes on the roof and we point different kind of cameras up there. And then there's a lot of international institutions that are involved in this collaboration. In the background there, we also have the IceCat Svalbard radar as well. So there is a lot of space physics instrumentation on Svalbard. And this is a picture at nighttime with the observatory. So above you see Aurora, but it's a kind of more special type of Aurora for Svalbard because it's dayside Aurora. So this could be happening at like 9 o'clock in the morning. And because we have polar night, so months and months where the sun doesn't come up at all, we can also see Aurora at 9 o'clock in the morning. And this is characteristic because it's more red than green because we got this lower energy particles coming in and causing it. So just to talk about that, there are these kind of funnels in the Earth's magnetic field that more directly take things in from the solar wind and interplanetary magnetic field, IMF, and they don't accelerate them that much really, and things just like flow pretty slowly down into the ionosphere and collide, making these lower energy red emissions compared to the type of aurora that you're probably used to seeing, where you get a lot of acceleration from the night side region. We also have this auroral oval here over Svalbard. So you can now see it on a map. So here we have like Norway underneath, and then the island with the red dot, that's Svalbard. So you can see we're pretty close to the North Pole, this red dot here. And this red aurora is the cusp aurora, we call it. So that's why it's color-coded red in the app because of this lower energy. But not only is Svalbard in a good place for looking at this cusp aurora, but we also catch a lot of the time this northernmost boundary of the auroral oval. So, I mean, even though in the nighttime we're actually a little bit not ideally positioned to see the night side aurora because we're quite high latitude, we quite often catch this boundary. Here is a video from the Shell Hendrickson Observatory. So here we have the fish eye lens again, a little bit like the Aurora eye, where we can see the whole sky. And we see an arc forming in the middle here. And then we see some strange features above the arc dancing around in a chain. So these are called fragments or fragmented aurora-like emissions in the literature, fragments for short. Sometimes they're appearing alone, sometimes they're appearing in chains. In a second, we see quite a nice chain in the middle here. It's coming there, which is really cool. So that's the main topic of my research, and you also may remember it because Josh Dreyer and Dan Whiter gave a talk on Aurorasaurus some years back when they first published about these features that they saw they published in 2021. So the research is still pretty new and not so much is known about them. But what we do know is that if we have the magnetic field direction, which points almost vertically downwards where we are because we're so close to the North Pole, and we have particles coming in and making what we're calling here normal aurora, we see things that line up with this direction because that's the guide for these particles coming down from the magnetic field in the near Earth space. And then we see all of these different colors along the way. But with the fragments, we see them at like a very specific altitude and they kind of flow in the perpendicular direction to this field line. So it's not normal behavior and maybe can consider not to be like classical aurora. Another thing that we saw cropping up near these fragments was what we're calling either continuum or continuous emissions. So it was here actually, just missed it. Here, yeah. So sometimes we see this appearing and it's in this mauve color, which is similar to Steve. So we were like, okay, that's interesting. And it's another kind of weird type of aurora because normally we have these very specific colors inside of the aurora, like these reds and greens and blues. But with continuous emissions, we see all of the colors that when you combine them together, it makes this off-white color. So again, not really classical aurora. Um, I asked people in the Longyearbyen community, have they ever seen this before, at a talk last year? And then practically the next day, one of the photographers got back to me with hundreds of examples that she had seen. She went back through many years on her hard disk and she found some really, really cool pictures of the fragments. So then it was really nice because I was able to use these to communicate to people what they actually look like out of this distorted fish eye view. So that was Sophie Corden, who was sending all these images. But then I also got a response from further places away, either privately or that people had posted on the internet and then other people had said, hey, look at this. Um, but we also saw that we see the fragments over Iceland and also over Greenland and even in Antarctica. So yeah, you can see here actually that there is some penguins watching watching these ones down there. So that was pretty cool. So we're seeing them in a lot of different locations. When it comes to these continuous emissions, we also had a really nice image of them from Marianne, who was in the Arctics team as well. So this was over Svalbard, and this was on one of the days that we're researching for a paper. So we'll use her image to show that we can see these. Actually, these are behaving a little bit more like a field-aligned aurora here. So that's very interesting. So we had images from Marianne of the continuum, and also we had one from Les as well in New Zealand, who's in Arctics too. So we're starting to see these emissions popping up. They're a little bit more difficult to identify because white aurora can be due to people's white balances on the camera or overexposure as well. So this is a little bit more tricky to easily identify or concretely identify from images alone. Here is a beautiful picture from Donna, where we see now maybe a little bit more what you're used to from down there, I guess, where on the equatorward side of the oval, then we're seeing Steve. So we have the continuous emissions from Steve that are sometimes seen with this picket fence, which is field aligned. But at the bottom of the picket fence, then we have these feet that stick out in a little bit perpendicular direction sometimes. And these are called streaks in the scientific literature. So the fragments, they're very comparable in size, lifetime, color, everything to the streaks. And emission-wise, the continuum is quite similar to Steve, but it seems to have a little bit of a different behavior otherwise. So what we're kind of interested in is comparing these two systems that we're seeing kind of on either side of the oval so that we can learn more about what causes these types of emissions and if different things can be responsible. But why should we do this? What's the point? The continuous emissions, they can be really hot. So they can actually cause the atmosphere to expand. And this can cause drag on satellites, which can slow them down and change their trajectories. So in the continuum case, we're more thinking about this atmospheric expansion perhaps being a problem that results from it. And from the fragments, we see these kind of regularly occurring stripes a lot of the time, which suggests that maybe there's some kind of wave responsible for it in the ionosphere. So, these waves, they can actually cause problems for communication and navigation systems in satellites and disturb signals. So as we become more dependent on satellite technology and put more satellites and manned missions into orbit, it becomes more important to understand these effects. So now the space mission. So that was kind of the research background. And then how does this space mission link into things? Like the mission is named Fram 2, and it's named after this Fram ship, which was a Norwegian polar exploration ship, really historic vessel that was going to the Arctic and also to the Antarctic as well. So this mission is named after that because of the regions that they will cover. And the link with Norway is actually quite nice because Norway has quite a rich heritage of combining the polar exploration and research. So this is Christian Birkeland, and he's an example of the pioneering work in linking Aurora to solar activity and Earth's magnetic field. So he was actually on the banknotes in Norway for the 200 NOK note until 2017 when he was replaced by another Norwegian treasure, which is the codfish, also very important to Norwegians. So the mission, it will be in a polar orbit. So that means that the satellite, not satellite, space mission will go over the North and the South poles, and it will kind of repeat like that. And there's never ever been any humans that have done this before. So that's why it's very exciting. They'll be the first ones to look down and see these regions, and the first ones that really have a good chance of imaging the aurora continuously, because the ISS orbit is much lower than this, like almost half the inclination. So this is a very good opportunity for them to view the aurora from space. So they're in the polar orbit, and the mission will last for 3 to 5 days. And I am happy that as of today, I'm allowed to say that it will probably go in March 2025. So that's the planned launch date. We want you guys, like from the ground, to be able to know where it will be, so that you can take pictures kind of underneath where they will travel. So you can download this app, the Aurora Forecast 3D app, which is developed by one of our colleagues at UNIS. And at the moment, the trajectory it's not open or anything, but we're putting it in this app so that you can look and you can see, okay, in my sky over my location, at what time and where will the space mission fly. Um, this is Yannicka. So although all the astronauts are involved in the research and are helping with planning and carrying out everything, Yannicka was the one who initially approached me about the project. And she is gonna take a camera with her because she is actually a professional cinematographer. And she's going to take images while she's up there for research on Northern Lights. So currently, there's not really that many satellites that capture auroral imagery in general, and the ones that do focus more on capturing large areas of the auroral oval, which results in inadequate resolution for our purposes of seeing these very small, fast-moving features. And other ones that maybe do capture in a high resolution do it in a very limited wavelength range. So yeah, we want from Yannicka, who can take whatever she likes up in this space capsule as long as it's not too heavy. We want her to take like a very high range like camera with high resolution, full color. We also like that she can adjust the settings while she's up there herself, depending on, what is going on the ground, which is a little bit more of a hassle to do with satellite missions. And then when we have her images, we want to combine them from like the images from space and then the images from the ground, so we can do some sort of triangulation and reconstruct these features in 3D so that we can kind of get an idea about these structures and if there is variations inside of them and try and figure out what's exactly causing them. So that brings us to the Solar Max project. So in the project, which is obviously named after the high activity of the sun right now, we want to gather as many people around the auroral regions as possible. This includes North and Southern Hemisphere. And we want them to take pictures of the aurora, and the most important observations are the ones below where Fram will be orbiting. So we want to reach out to as many people as possible with the media and social media communications. We want to stress that anybody can be a part of the project. You don't have to be a photographer, you just have to have a camera or mobile with a camera on it. Yeah, we also want to reach out to people who operate ground-based instrumentation and satellites also. and actually say, hey, is there anybody out there who can turn your instruments into any specific modes? So, I mean, here we have Jeremy's Aurora because we've been discussing a little bit what possibilities could there be there. But we want to reach out to people if there's any way you can change your instruments resolution to during these 3 to 5 days, then please go ahead. And then we want to kind of educate people, what do these features look like, so they know if they're seeing it and they know they can report it and that we're interested in it. So then in the Arctics team, we've been developing these resources that me and Donna are going to show you. And then when it comes to FRAM 2 launching, the public should then be ready, hopefully, with these resources to take pictures on the ground so we can get this imagery from the ground in the space. So hopefully we get some nice Aurora and we see some of these features that we're interested in and the public knows and then they can report them. So this we can either do with the Aurorasaurus, obviously, or with the Skywarden website as well. And perhaps dividing the traffic is maybe a good idea, it sounds like. um, but then we really don't know what we will see on these days. It could really be anything. Hopefully, it's the things that we're looking for. Perhaps it's something completely new. Perhaps we see something really cool that we didn't even anticipate that other researchers can use. So I really focus on getting this open database so that whoever has expertise in what is seen is able to write papers and push forward the scientific knowledge in this area so we have as much scientific impact as possible. Finally, just to show you, this is the homepage on the SolarMax site. So you can go on this link, solarmaxmission.com. And then here it will show you some images of the things that we've covered that we're interested in. You can click and you can learn more about the mission and about the people involved. And then also get some resources for yourselves as photographers and citizen scientists, or like flyers and posters to distribute to tell people about what we're doing here. So yeah, I hope that some of you guys are interested and want to be a part of it. I would really love to have even more of you on board because yeah, there's already some people who have joined. But thank you so much for your attention. Now I would like to pass it over to Donna, who can show you the field guide that we've developed and talk a little bit about her experiences with Arctics and what she got out of it.
Thank you so much. Great talk. Donna, you are muted. I'm sure you're getting all the things. We can see your screen.
Okay. You don't see my screen, do you?
No, we do see your screen.
Oh, you do see the field guide screen?
Yep. Yep.
Okay. Oh my goodness. Okay. All right. Okay. I yeah, we were able to publish it yesterday. Katie has put in so many hours of work getting this accomplished, and I've been very grateful to be able to work with her on this and in the Arctics team, and as well as some of the other ambassadors who are on the call, Carlos and Vincent. They're also part of the team, and it's been an amazing process. When we started working on the handbook in January, it was very intimidating for me, and I realized that I had to just set aside my ego and take the plunge and admit that I didn't know how to do some things. And as I took a dive into it, I learned how to work with some of the tools. And one of the things that we, pardon me, we're talking about, we're studying different features, and the challenge to communicating between the scientists and the citizen scientists about what the features were was that as a citizen scientist photographer, I needed to know what they looked like. Having just a description um, didn't really cut it for me. And there was things like the continuous emission or the continuum that I really wanted to know what it looked like. And it took me about 6 months to understand. And I still have lots to learn about it, but that's one of the features that SolarMax is going to be looking for. And I really wanted to learn about it. So that kind of brought us to the need to have a field guide alongside the handbook that would have some pictures, not for official scientific um, um, classification, but for communication, so that we could have something to compare our photos that we get from the ground to what the scientists are talking about. And my perspective is subauroral, so that I realized is so different depending on your location. If it's polar or rural, subauroral, or low latitudes, the aurora looks so different. So we put together this field guide that covers some of the features that and it can be accessed by a phone or on the computer. It's done in 16:9 orientation so that it can be viewed fully on sideways on your phone or on your computer screen and or in the Adobe app. And I'm not sure how you're seeing it right now, but it's not flipping page by page in the Adobe app. You can do it that way, or you could just scroll through it um, on your phone or on the computer. And the photos that we got are photos from the members of the Arctics team, and there are some images that explain how to take photos for science, which is all covered in the handbook. But this is very brief document that people can use in the field just to get some basic tips and some easy methods of identifying things. One of the things that I found very fascinating was about the blue aurora. And it when we were talking with the scientists from Svalbard, they were showing me pink aurora, and I thought, well, that's not blue aurora. But then it was explained to me that the how the colors happen, and the explanations that we have on the screen here are not necessarily scientific explanations, but it is explanations for people who are viewing it, so that it can describe to someone just looking at it what you're actually seeing. So it's been quite fast. I know our discussions, we were looking through the photos as to what to use for the features, having the discussions between scientists and citizen scientists, we learned so much from each other. The scientists don't necessarily see the aurora all the time, or definitely not as much as those of us that are on the ground taking thousands of pictures in a night. And in our discussions with each other, I know I have learned so much over the last 6 months to a year from having these discussions. And, you know, I've learned so much from Liz over the year and what she shared with me, and combining that with what I've learned with looking at these photos and having other discussions. It's so rewarding for me as a citizen scientist to be able to have that communication, the collaboration, and learn so much and make a difference for other people who are out in the field. able to give them the tools that they can do the same thing and contribute to these projects like SolarMax and encourage people to report to Aurorasaurus and Skywarden so that these observations can be used in scientific study. We have made such amazing progress in collaboration over the last few years between scientists and citizen scientists, and it's very exciting for me to be a part of it. I will now pass it over back to Katie to talk about the handbook.
That's amazing, Donna. Looks beautiful and looks really excellent and very useful.
Yeah, thank
Thanks.
you so much, Donna, for sharing your experience and you shouldn't just say that I put a lot of work onto this because you put so much work into it as well. So you should receive the recognition for that as well. And it's so nice to have a place that you can also share all of these beautiful photos, and we're so grateful that you let us use them as well. So thank you so much. Um, okay, so I can share the handbook as well now. I guess you see this. Good. So this is a page that I just posted in the chat, but it shows you both the field guide and the handbook. We also have a DOI as well for citations and yeah, licensing and everything. But you can view the handbook either as a PDF by clicking here, or you can also view it online on a web page as well. So I can go over to the web page. And the page can also be put in dark mode, which is pretty nice. I think that's actually nicer. But you see the main sections on the side here. So yeah, we have like, yeah, introductions and stuff, and then a little bit of a talk about Aurora chasing, Aurora etiquette, and like when to go outside, how much to rely on KP index compared to like, interpreting the BZ. But we do not go into like loads and loads and loads of detail, but just a little bit to kind of get get people engaged and familiar with the terms. But we talk in quite a bit of detail about the Aurora research and the citizen science because that's more what we're gearing to here. So we show examples like Steve and the fragments and dunes as well, and tell a little bit of their story about how they were discovered. And then we have like sections on how to take an Aurora photo. So this is where the photographers really, really, really helped because I'm not a very so good at I can try, but I'm not I don't know what all the words mean. So yeah, it was really nice to have the photographers on the team to show how to basically do that and also how to take images for science because of course we need the timestamp, accurate timestamp and location as well, pretty critically. But you can adjust other features in the camera to collect data for other specific types of aurora, and that's kind of discussed in here. And then we talk about identifying and reporting the aurora, where we refer over then to the field guide, because initially we started putting images into this document, but then the document just became lots of images, and then it didn't really work with this text document and then the massive amount of images that we wanted to put. So that's how things initially got spread out into two, so that people could just look at the pictures in the field guide and flick through those and look to the handbook for more information. So if you click on like read more in the field guide, then it will take you over to the handbook and to the right section. And then we kind of we talk about advices both to scientists and citizen scientists on collaboration, so reciprocity and attribution, and how to work together generally, which was interesting to write, and we had a lot of useful discussions around there. And then finally, there was some advice for scientists on how to manage the data. So you can click on anything down here, and then it will take you there. Why to study the aurora. Yeah, like when to go out, and all of these subsections are available here. The Steve and the SAR arcs. Yeah, everything is listed down here. Won't go through it all. You can check it out yourself, but it's yeah, it's a very I wonder if we can see an Aurorasaurus here. There's an Aurorasaurus section somewhere. Yeah, there it is. This one here. So I was watching Vincent's video on how to submit an observation and just written some brief notes here on how to do that. just so this can act as really like a kind of accompanying guide to the citizen scientists, so they see all of the steps in taking the picture, identifying, reporting, and working with the scientists. So even though it's also for scientists as well to know how to reach over and address the citizen science community, like I think it has stuff for both parties in there, which is really, really nice. Um, so I can stop sharing there, but if I have just another 2 minutes, I would just like to kind of share a little bit my experience. Do you finish 5 minutes sharp? Is it over in
Uh,
5?
no, I think you can go on a little bit. Yeah. If
Okay.
people have to leave, they have to leave. But
Yeah,
thank you.
yeah.
Yep.
I
Mhm.
I just wanted to because I just wanted to say like that I had learned like so much from the citizen scientists, and like it was really amazing to me to meet someone like Donna who would go through a whole evening of auroral observations and identify all of these different types of aurora and just have that experiential knowledge of how long these things last and how they change in different conditions, all of the different ways that she had seen them. So that really amazed me because as a scientist focusing on one thing, I don't really feel like I have that experience. So it was really, really cool and interesting to learn from the citizen scientists. And also, it kind of helped me make these connections to the photographers, aurora chasers, community leaders, and have these discussions about collaborative work and the attitudes towards different things and social media. So for me, it's given me like a little bit more confidence with how to navigate social media because, I felt like I had negative experiences with critical comments, but now I can see it's possible to like build up trust in these communities and community leaders and have a more of a nicer and productive experience and use these more moderated places as like a safer space on the internet to get involved with. And yeah, like I kind of saw that the Citizen Science Network is just so widespread and the availability of the smartphones and cameras is like never before during the solar maximum. So after Arctics, I kind of saw the potential for the collaborations with the scientists. And when I got the opportunity to work with the Fram 2 astronauts, like I knew that I wanted like the citizen scientists in the team because I knew how valuable that would be. So I was it was a really rewarding experience. And when I got this opportunity, I thought, okay, usually with the citizen science collaborations, we see something in their photo and then we go back and then is there any space instrumentation passing overhead? What other instruments can be used? But I really wanted to like flip that on its head and just say, okay, now we're putting the astronauts up there. This is the things that we're looking for. This is how to take the picture and how to report it. And please go out and do that because we know at these times now we're going to have these images. So I thought that was really cool. I mean, I don't know what will show up on the day, but at least like we tried our best to to change it and plan something in advance and get the observations that way. So yeah, thank you very much.